Now we're going to work primarily with a diagram, a very famous diagram in the history of economics, and it's a diagram that's going to enable us to say a great many useful things about the nature of a macroeconomy operating in the short run. And I'm going to build the diagram up for you slowly and carefully. We won't complete it in this lecture, but I'll give you some important key starting points. The first part of the diagram will be a vertical axis on which we record the economy's planned aggregate expenditure. So the vertical axis in the diagram will be a means of recording the amount of planned aggregate expenditure that sectors in the economy are anticipating over a particular time period. On the horizontal axis, we're going to measure the economy's actual GDP. Remember, GDP can be thought of as production or income or expenditure, and you'll see that distinction isn't really that important in this analysis, as we're going to draw on all three of those concepts at various points. So we have two axes, one on which we record the economy's planned aggregate expenditure, the vertical axis, and the horizontal axis on which we record the economy's actual expenditure, or if you like, its GDP, which is also a measure of actual income or actual production. To this diagram, I now add a line which begins at the origin and then extends out at an angle of 45 degrees. And this line is often referred to quite simply as the 45-degree line. It's an important line in the context of the diagram because it represents some incredibly important concepts. And what we're going to do in this diagram is really bring together in a very systematic way a whole lot of the concepts we've been talking about up until now. For example, let us suppose that the economy, the sectors in the economy in aggregate, have set their spending plans to be equal to 100. Now, where that number comes from will develop in more detail in our next lecture. For the moment, let's just assume that our households, firms, government and foreign residents have decided that over the period we're talking about, what they would like to plan for is a flow of expenditure equal to 100. If over that period it turns out that firms in the economy also produce 100, then we are looking at a situation that matches our definition of equilibrium. Because remember, an equilibrium is a situation defined to be where planned aggregate expenditure equals actual GDP. Or to put it simply, what firms are planning to produce corresponds exactly with what the sectors in the economy in aggregate are planning to spend. So that this point here on the 45-degree line can be viewed as a point of equilibrium for the economy. Let me now show you how this analysis can be used to illustrate not equilibrium, but disequilibrium. To do that, I need to add a second element to the vertical axis, aggregate expenditure. So on the vertical axis, I'm going to measure both planned aggregate expenditure and aggregate expenditure itself. Remember, that refers to what actually happens. So let's suppose that our sectors in the economy have collectively decided over this period that their planned aggregate spending will be equal to 100, as before in our previous slide. The difference, however, is that we're now going to assume that firms in this economy, for whatever reason, are producing 140. So we have a situation where our criterion for equilibrium is not satisfied because we now have more output being produced than is warranted by the planned aggregate spending of sectors in the economy. Note, and this is why I wanted to have aggregate expenditure on this diagram as well, because of the definition of GDP, we know that that figure of 140 also corresponds to aggregate expenditure in the economy. So that this 45-degree line that we previously used to illustrate what an equilibrium would look like also comes into play here, reminding us of the equality between GDP and aggregate expenditure. But here we are not looking at an equilibrium, we're looking at a disequilibrium. And we can decompose what's going on in the following way. That planned aggregate expenditure of 100, remember, comprises the spending plans of households, the planned investment by firms, the spending plans of government and the spending plans of foreigners on exports. Collectively, that must sum to equal 100. But actual expenditure in this economy is 140. We know that because the flow of production must equal the flow of expenditure. So there's another 40 units of expenditure taking place here. That additional 40 units of expenditure is actual unplanned expenditure. And it is in fact an unplanned increase in inventories, which represents expenditure by firms. It represents unplanned investment expenditure. And that can be measured either horizontally here or vertically here. It doesn't really matter that much. The point is what you're looking at is a situation of disequilibrium. Firms have produced 40 units too much relative to the spending plans of the economy. That surplus 40 units is going to show up as actual expenditure, and that occurs because it is recorded as investment expenditure by firms, but it's an unplanned expenditure by firms. It's associated with unplanned inventory increase. Or to put simply, you're looking at an economy over this time period that has produced too much relative to the spending plans of all of the various sectors. Now, the key question, and this is really what we're going to be exploring in some detail, and this really is the key question in business cycle analysis. On the horizontal axis, I've now recorded the economy's potential GDP. How do I know the potential GDP is at that particular point on the axis? Well, there's nothing in the model, there's nothing in this analysis, if you like, that tells me necessarily where potential GDP is. That's coming from growth economics, if you like. That's coming from the fundamental structural forces in the economy that determine its potential GDP, and those forces don't play an active role in this analysis. So why is potential GDP at that point? It's because there's a whole lot of things that are happening outside of this model that determine potential GDP that have resulted in that being this economy's particular flow of potential GDP. Now, in macroeconomics, and this is a word you're going to hear quite frequently, a variable that is part of a model but whose value is determined from outside of the model is known as an exogenous variable. An exogenous variable is a variable whose value is determined by factors that are operating outside of the model. Those factors in this instance lead to that particular level of GDP being associated with this economy's potential GDP. But there's going to be nothing in this analysis that necessarily tells us exactly where that point is. It's given to us from outside of the model. Now, from the viewpoint of a macroeconomic policy official, say the chair of the Federal Reserve or the chief finance minister, then what one of their aims presumably will be to manage the macroeconomy so that its actual flow of GDP corresponds to that potential. In other words, to not have, for example, an economic contraction where actual GDP was below potential. So you can think of Y star as being a goal, one of the goals of short-run macroeconomic policy, to manage the economy so that actual GDP corresponds to Y star. I want to contrast the notion of an exogenous variable, which we've just been talking about, with what is known as an endogenous variable. An endogenous variable is determined from within the model. In other words, the model tells us what factors influence the value of the endogenous variable. The model can be used to predict what value an endogenous variable might take. So, broadly speaking, in all economic analysis, we often make this distinction between exogenous and endogenous, where exogenous variables play a role in the model, but the determination of their value is external to the model. Endogenous variables are actually built into the model. The model tells us exactly what happens to an endogenous variable. Now, why is this distinction so important? Why is this the key question? It's because of this. Suppose we go back to that first illustrative example when I introduced the concept of equilibrium to you. Suppose the economy's equilibrium was that point here, where planned aggregate expenditure and actual GDP coincide at 100 units. I'm going to label that equilibrium as endogenous, and in our next lecture I'm going to show you how this model actually tells us how that endogenous point is arrived at. In other words, I'm going to develop an analysis that tells us why the economy's equilibrium is where it is. And this is the key question addressed by Keynes. Potential GDP is exogenous. It's determined by forces outside of this short-run macroeconomic analysis. In the short run, however, there are forces that lead to a particular equilibrium being established. So there we're talking about an endogenous outcome, an outcome that is predicted or explained by the model. We have two quite distinct sets of forces going on, in other words. We have exogenous forces, which are setting the economy's potential GDP, but operating outside the model. And we're going to have forces, macroeconomic forces, operating in the short run within this model, establishing where the economy's equilibrium is. And because these exogenous and endogenous forces are quite distinct, in this short-run macroeconomic analysis, there is absolutely no reason in general why those 2 points should coincide. And this is one of Keynes' most fundamental insights. In the short run, in a macroeconomy, the forces that determine the endogenous equilibrium have no systematic relation at all to the exogenous forces outside the model that determine the economy's potential GDP. It is possible, in other words, to find the economy in this situation where it reaches an equilibrium at a level of GDP below potential. And that's the theme we're going to explore in our next lecture, where we're going to focus on the endogenous determination of the economy's macroeconomic equilibrium. In our last lecture, we started the construction of what's called the basic Keynesian model of the business cycle. This is going to be a representation of some of the key ideas that Keynes was keen to put across in his book, The General Theory of Employment, Interest and Money. And I introduced you to some very important concepts, in particular this notion of macroeconomic equilibrium, a situation in which there is equality between the planned aggregate expenditure that is being undertaken by the various sectors of the economy and the actual amount of output, or GDP, that is being produced by one of those sectors, the firm sector. An equilibrium in this framework is defined to be a situation of equality between planned aggregate expenditure and aggregate output, so that firms are producing exactly what the four sectors of the economy are planning to spend. And that gives us a very convenient way of visualising equilibrium using the diagram you can see in this slide, where we record planned aggregate expenditure on the vertical axis and GDP on the horizontal axis, and therefore a 45-degree line in this diagram in fact represents that equilibrium, because by definition any point on the 45-degree line satisfies the condition for an equilibrium. Any point on the 45-degree line is a point at which planned aggregate expenditure on the vertical axis corresponds to output, or GDP, on the horizontal axis. And then a key concept that I introduced to you is this distinction between a variable that's exogenous and a variable that is endogenous. And you'll see that that distinction is absolutely crucial to understanding this particular approach to the business cycle. An endogenous variable is something that is determined within the model. Or to put it another way, the model provides us with an explanation of why the value of that variable is what it happens to be. The model explains that variable. An exogenous variable, well, that is determined by factors that are not explicitly incorporated into the model. An exogenous variable is determined by factors from outside the model, and therefore the model doesn't provide us with any real insight into what are the factors that are determining the value of an exogenous variable. Now, why that is so important in terms of understanding the business cycle is because, as you'll see, the economy's equilibrium is endogenous in this framework. That is, the model will explain for us in a very systematic, logical way where the economy's equilibrium is, or if you like, what the economy's equilibrium flow of GDP will be. What is exogenous to this model is the economy's potential GDP, Y star. We've already talked about the sorts of factors that might influence potential GDP. We looked at those factors in our material on growth economics. So we do have an explanation for what factors are important for Y star, but those are long-run structural factors in the economy. They're not part of this short-run approach to the macroeconomy. So they're very, very much exogenous factors. And you'll recall our discussion of the output gap when I first introduced you to the concept of the business cycle. An output gap being a situation where actual GDP differs from potential GDP. Well, here we're working with a framework where output gaps are very much a possibility. We're working with a framework that will tell us what the economy's actual GDP will be, and that's related to the concept of equilibrium. But because potential GDP is not part of this framework, because it's exogenous, the possibility of output gaps becomes a very real possibility indeed. The possibility that the economy's equilibrium, GDP, might differ from potential GDP and therefore an output gap might exist is, in this framework, a very, very real possibility. And that's the sense in which we're building up an explanation or a model of the business cycle, a model that will explain where do output gaps come from. The concept of planned aggregate expenditure is going to be the key. You'll recall that planned aggregate expenditure refers to the spending plans of the four sectors of the economy: households' consumption plans, firms' investment plans, government expenditure plans, and the plans of foreign residents for how many exports they plan to buy from the domestic economy. All of those are captured by the concept of planned aggregate expenditure. An important consideration for us as we develop this framework is the distinction between equilibrium, a point on the 45-degree line, and disequilibrium. What you're looking at in this slide is a representation of an economy in disequilibrium. And what I'm referring to is this point here, a point not on the 45-degree line. What is happening at this point is the economy is producing 140 units of output at a time where the planned aggregate expenditure in the economy is only 100 units of output. So we have a violation of our equilibrium condition. We are not dealing with a situation where planned aggregate expenditure and GDP are equal. Put simply, what you're looking at here is a situation where the economy has produced too much. It's produced too much relative to what agents are prepared to spend. There is going to be, in other words, unsold output. Firms are going to be accumulating, in other words, inventories of unsold output. But this is unexpected. This wasn't what firms expected to happen. Presumably when firms decided to produce this 140 units of output, this is what they expected to sell. That hasn't happened. The economy's planned aggregate expenditure has fallen short of what firms thought it might be, and to firms' surprise then, they have accumulated unsold stock of inventories, in this case 40 units of inventories. Now recall from our discussion of GDP that inventories are recorded as firms' investment. They're part of firms' investment because this is stock that can always be sold in the future. So they meet that definition of investment as being expenditure undertaken today that will only bring about a benefit at some point in the future. And so those 40 units of inventory will be recorded as unplanned investment. And so that's why in this diagram I've recorded that as I for investment with a superscript U. It's not what firms thought would happen, but it's the reality that firms now have to deal with. Planned aggregate expenditure, therefore, is going to be the absolute key to this. Equilibrium is going to require firms' production plans to be equivalent to the expenditure plans of the four sectors of the economy. And we're going to be spending a lot of our time, therefore, talking about planned aggregate expenditure. So let's begin, and I'm going to do it in the following way. I'm going to divide planned aggregate expenditure across the expenditure plans of the four sectors. So households' contribution to planned aggregate expenditure is their consumption. Now remember, the little superscript D next to consumption reminds us that this is consumption spending on domestically produced goods and services. We have firms' investment plans, we have government expenditure, and we have the expenditure plans of foreign residents on domestic exports. Now I'm going to focus on the bottom three rows of this table: planned investment, government expenditure, and exports. I'll remind you that an important assumption is that firms are the only sector in this economy where it's going to be possible for planned expenditure to differ from actual expenditure. And that's this distinction between planned investment and unplanned investment that I was talking about in the previous slide. But for households, government and foreign residents, we're just going to work on the assumption that what they plan to spend is what they will actually spend. Now, if we focus on firms' planned investment, government expenditure and exports, we're going to operate on the assumption that all three are examples of exogenous variables. That is, there could be a host of factors that influence those particular components of planned aggregate expenditure, but those factors lie outside of the model. Now, what's the rationale for that? When you first hear that, that seems like a pretty extreme assumption. In particular, why on earth should firms' investment plans be exogenous? Why are they sitting outside of this model of the macroeconomy? What does that actually mean? There is an important rationale for why we treat firms' investment plans as exogenous. And to understand that rationale, I'd ask you to go back and think about the nature of investment. An act of investment by a firm is quite literally expenditure undertaken in the current period, but with a view to the provision of benefits in the future. Think about it this way. A firm buys itself a new production line, and it does that in the current period. It's going to take time for that production line to actually produce output. It's going to take time to install it. It's going to take time to train workers in its use. It's going to take time for the production line to actually produce output. And then it's going to take time to get that output to the market and for that output to eventually be sold. So the revenue that the firm gets, which is the benefit for the firm of that act of investment, is going to be at some point in the future. So firms' decisions about current investment expenditure are not really going to take much notice of what the current state of the economy is, or any current considerations. It's going to be much more influenced by expectations about what the future might be. And the factors that influence expectations about the future, well, they lie outside of this model. We'll actually talk about some of them as we go through this material, but they're not formally captured in this particular theoretical framework. They're exogenous. Why is government expenditure treated as exogenous? Well, government expenditure is treated as exogenous because this is what's called a choice variable of the government. And within certain limits that we will talk about in a future lecture, governments can decide for itself what particular level of expenditure it wants. It doesn't necessarily have to vary that systematically with regard to anything in the model. So government expenditure is treated as exogenous because this is literally a decision of the government. Why exports is treated as exogenous is perhaps the easiest to see. Remember, exports are being purchased by residents in other countries, presumably for reasons that relate to those other countries. And they're completely exogenous to anything that's happening in the domestic economy. So the exogeneity of export demand, I think, is pretty apparent. So you can think of reasons why it's not unreasonable to take planned investment, government expenditure and exports as exogenous, and we're going to work on that assumption from here on. Collectively, we're going to label those three components using the letter J with a superscript P. Now, in macroeconomics, J stands for a term known as injections. And when you see me write J with a superscript P, I'm talking about the economy's planned injections. Injections is actually not a bad term for these three components of expenditure. They're exogenous. It's like injecting expenditure into the economy from external or because of external reasons. So injections is actually, it gets across the concept that these are indeed exogenous. Now we can illustrate planned injections very easily using the diagrammatic framework that we're developing with planned aggregate expenditure on the vertical axis and GDP on the horizontal axis. And we're going to represent planned injections using a horizontal line. The fact that this line is horizontal is no accident. In fact, that is very much a reflection of the exogenous nature of planned injections, because what this is telling us is it doesn't matter what level GDP is, planned injections are always going to be the same value. And that really is a reflection of the exogenous nature of planned injections. GDP is within the model, but changes to GDP, remember this is the current flow of GDP, have no impact on planned injections because planned injections are being influenced by factors that lie outside of the model. It's important to understand, however, that when we say planned injections are exogenous, we are absolutely not saying that planned injections never change. In fact, changes in planned injections are not only possible, they're going to be a very, very important part of the Keynesian story about where the business cycle, about where output gaps come from. So let's look at two instances where there might be a change in planned injections, and these are just examples. I'm going to focus on planned investment. Now, one of the factors that almost certainly influences planned investment is the cost of financing available to firms when firms are thinking about undertaking a piece of investment expenditure. A lot of investment expenditure is financed through borrowed funds. If you think about the nature of investment, it almost has to be that that's the case. Because remember, investment is expenditure undertaken today that will only yield revenue for the firm when the output is eventually sold at some perhaps distant point in the future. Well, if the investment is only going to generate revenue in the future, where are the funds going to come from to undertake the investment expenditure in the first place? The answer is from borrowing those funds. And so the cost of the borrowing, the cost of financing is going to be an important consideration for firms when they make their investment plans. How easy is it to obtain financing for investment? and the ease with which financing can be obtained, and indeed the cost of that financing, the interest rate, for example, that banks charge on those loans, all that can vary. That's an exogenous change. It's nothing in the model we're developing that tells us why those changes might happen, but those changes are a fact of life. So you might, for example, be dealing with a situation where funds are more easily obtained. And that could encourage firms to increase their flow of planned investment expenditure, and that would be represented by a horizontal upward shift in the planned investment schedule. Could go the other way. You might be dealing with a situation where funds become increasingly difficult to obtain. Banks might be withholding the credit they're prepared to extend to firms, or they might increase the interest rate that they charge on those loans. Either of those two factors might discourage firms from undertaking some planned investment, and that would show up by a horizontal downwards movement in the planned investment schedule. So to repeat, simply labelling expenditure as exogenous is not the same as saying the expenditure never changes. In fact, those changes do occur, and they are important, as you'll see in this framework. It's just that the model provides us with no explanation for those changes. Those changes are being generated by factors that live outside of the model. That leaves consumption. Consumption, the fourth component of planned aggregate expenditure, which we haven't said anything about yet. The way we treat consumption is going to be a little bit different from the way we treated the components of planned injections. With consumption, we're going to recognise that there are two distinct types of consumption expenditure undertaken by households. The key to this is the concept of disposable income. Disposable income refers to the income that households have left over once they've paid their taxes. Another term for this is after-tax income. There's going to be an important component of households' consumption spending which is directly influenced by disposable income. That is going to be endogenous, because we will be able to say something about that part of household consumption from within the model. And that's because the model is going to give us insight into the factors that determine aggregate income in the economy. So one important part of consumption is endogenous, because it is going to be directly affected by disposable income. Think about your own consumption behaviour. For most households, an important consideration in how much consumption can be undertaken is in fact their after-tax income. But we're also going to recognise that there could be a host of other factors that also influence households' consumption expenditure, factors unrelated to disposable income. We don't know what all of those factors are. They live outside of the model. Therefore, there's going to be a component of household consumption that is exogenous. So let's develop this, and I'm going to develop it using the concept of the consumption function. It's just a very simple algebraic representation of the idea that I explained in the previous slide, that household consumption has these two components. So on the left-hand side of this equation, we record the total flow of household consumption expenditure over a time period. The little d there reminds us that this is household expenditure on domestically produced goods and services. C bar on the right-hand side is that part of household consumption expenditure which has been determined by factors other than disposable income. And so there we collect the sum total of the exogenous consumption undertaken by households. This term, y minus t, Y, you recall, is our notation for income, T is our notation for taxation. That term measures the disposable or after-tax income that households have available. That leaves this term here, lowercase c. Lowercase c turns out to play a very special role in this analysis, which we'll develop fully as we go forward. It's known as the marginal propensity to consume. I'll explain exactly what that means in a moment, but first I just want you to note that what we're actually talking about is a number. So lowercase c is actually representing a number, but there's a restriction on what values that number can take. It has to lie somewhere between 0 and 1. And a typical value might be 0.75. What does that actually mean? The marginal propensity to consume tells us that should a household receive an extra $1 of disposable income, then in this instance, 75 cents of that extra $1 will flow into increased consumption expenditure. So the marginal propensity to consume is a measure of the proportion of any increase in disposable income that is received that flows into increased consumption expenditure. So take a household that gets an extra $1, and suppose its marginal propensity to consume is 0.75, so 75 cents of that extra $1 is used to finance some extra consumption. What happens to the other 25 cents? Well, that can be used either for saving, or it could be used to purchase some imports, or it could be used for some combination of both. So the $1 gets allocated across some extra consumption, some extra saving, some extra purchases of imports. What about taxes? How are we going to treat taxes? In the consumption function, we've just written capital T there, which just stands for the total amount of taxes paid by the household. We can actually say a little bit more about taxes, and this is the approach that's often undertaken in this analysis, and that is to divide taxes into two distinct components. One component is going to be an exogenous component. This represents any taxes that the household needs to pay that do not vary systematically with the household income. So there might be some fixed license fees, for example, collected by the government for various purposes. And then we have an endogenous component of taxes, where this does systematically vary with the income earned by the household. Little t here, think of that as the tax rate. For example, it might be a number like 0.2. 20% of household income in this example is collected by the government in the form of taxes. So this is a very simple version of the tax system. The tax system, of course, is incredibly complicated in all countries, but most tax systems have elements of either exogenous taxes and certainly endogenous taxes. So whilst this is a very simple tax system, it's not completely removed from the tax systems that exist in reality. So if we take that little tax system and substitute it for the overall measure of taxes in the consumption function, we end up with the following expression, so that household consumption in total is going to depend on this exogenous consumption. It's going to depend also on the exogenous taxes that are paid, and then it's also going to depend on what's left over from income after we take out the endogenous component of taxes. We can illustrate this visually quite easily, and this is how we're going to proceed from here on, using a diagram with household consumption on the vertical axis and income on the horizontal axis. The consumption function will be illustrated in this framework with a positively sloped line. The height of that line on the vertical axis, the vertical intercept, will reflect the exogenous consumption as well as the exogenous taxation. And the slope of the consumption function will reflect both the marginal propensity to consume and the tax rate. And should either the marginal propensity to consume or the tax rate change, then the slope of the consumption function will also change. So we now are starting to get a very complete picture of planned aggregate expenditure. It has three very clear exogenous components, our planned injections, and here I've just added in some arbitrary numbers to give us some structure for this picture of planned aggregate expenditure that we're building up. So there's nothing special about those numbers. I've literally just made them up. Consumption, slightly more complicated than planned injections because it has both an endogenous and an exogenous component. Again, I've just made up some numbers here that don't seem unreasonable. Marginal propensity consumer 0.5 and a tax rate of 0.1 or 10%, and then I've just arbitrarily chosen some numbers for exogenous consumption and exogenous taxes. And then we also have an endogenous component which I've written for you in the top right hand part of that table. So what we have there is a complete representation of planned aggregate expenditure for a particular economy. I want you to note something. Whilst a great deal of planned aggregate expenditure is indeed exogenous, there is an important endogenous component, and that comes through consumption, and it comes through the fact that consumption varies systematically according to what is happening to income. So that planned aggregate expenditure, whilst a lot of it is exogenous in this framework, has a very important endogenous channel coming through income, in particular coming through the way that income in aggregate affects household consumption. And as an exercise, I'd like you to attempt to recreate this table. So what I've done in this table is on the first column, I've simply arbitrarily chosen various different flows of income, starting from 50 and going through to 150. In the second column, I've taken the information from the previous table and constructed measures of planned aggregate expenditure that correspond to each of these income flows. I'll remind you, the planned aggregate expenditure in total is consumption plus planned investment plus government expenditure plus export. So simply take that information from the previous table, combine it to get an expression for planned aggregate expenditure, and then substitute in the various different income flows and make sure that you are able to see what the corresponding planned aggregate expenditure is. Note the following. There is clearly a systematic relationship going on here between planned aggregate expenditure and income. The higher is income, the higher is planned aggregate expenditure. The third column is particularly important. It shows for each and every of these various income flows what the difference is between that flow of income. Now remember, income's GDP is the same as output. What the difference between that income flow is and planned aggregate expenditure. And I want you to note there is one and only one instance where there is no difference between the economy's aggregate income and its planned aggregate expenditure. Here we have satisfied our condition for macroeconomic equilibrium, and only there do we satisfy that condition. Everywhere else you would be looking at disequilibrium. I'll just write DIS for disequilibrium. It is only here that we have a particular income flow that has associated with it a flow of planned aggregate expenditure that gives us an exact match between that income flow and planned aggregate expenditure. What you're looking at there is the one unique instance for this particular economy that we are dealing with where we have the equilibrium condition being satisfied. The economy that we are working with, our hypothetical economy, to illustrate the basic Keynesian model, reveals to us the unique equilibrium which occurs when the economy's GDP is 100. Remember, what happens here is with GDP of 100, with an income flow of 100, in other words, the flow of planned aggregate expenditure is also exactly equal to 100. There's no divergence between GDP and planned aggregate expenditure. We have the equilibrium condition for this economy satisfied. It can be a bit cumbersome working with a table like this all the time. So what I want to do is take this information that we've collected about planned aggregate expenditure and illustrate it on a diagram. So the diagram we've already started to construct. It has planned aggregate expenditure measured on the vertical axis and the economy's GDP measured on the horizontal axis. And then all possible points of equilibrium are represented by points on the 45-degree line. Remember, by definition, any point on the 45-degree line satisfies our condition for equilibrium, because any point on the 45-degree line will correspond to where planned aggregate expenditure and GDP are equivalent. The question we need to answer now is which of those possible points of equilibrium will actually emerge as the economy's actual equilibrium. To answer that question, we take all of the information we've collected so far on planned aggregate expenditure and illustrate it on the diagram. So let's start with planned injections. You'll recall that planned injections can be represented visually by a horizontal line in this particular framework, where the fact that this line is horizontal reflects our assumption that the spending plans of firms, government and foreign residents are exogenous, so they don't vary systematically with current GDP. Using the numbers in the table that we've been working with, the economy's planned injections will have a numerical value of 40. The next component of planned aggregate expenditure relates to households, and households' expenditure plans are summarised in the consumption function. Again, using the numbers, the hypothetical numbers from that table, the consumption function can be illustrated in this instance by a positively sloped line with a vertical intercept of 15 and a slope of 0.45. I'd ask you to recall that the slope is influenced both by the marginal propensity to consume and by the tax rate. So those two lines are actually incredibly informative. They tell us everything we need to know about the expenditure plans of every sector in the economy. There's nothing missing here. We've got households' expenditure plans, firms' expenditure plans, governments' expenditure plans, and foreign residents' expenditure plans. It's all there. And if we combine that information, if we take planned injections, in other words, and add it to household consumption, we end up with a complete representation of this economy's planned aggregate expenditure. You'll see that planned aggregate expenditure has a positive slope. In fact, it has the same slope as the consumption function. That's important because it reminds us that planned aggregate expenditure has a significant endogenous component. In other words, because variations in income lead to variations in household consumption spending, variations in income also lead to systematic variations in planned aggregate expenditure. So planned aggregate expenditure has an endogenous component. It's different for different flows of income. But it also has significant exogenous components, primarily coming through those planned injections, but also remember that consumption itself has some exogenous elements. So planned aggregate expenditure in total has both components that are exogenous and endogenous. The point at which planned aggregate expenditure crosses the 45-degree line is very significant for us. That point represents the economy's equilibrium. The way to understand that point, or the way to interpret it, is as follows. Should the economy's GDP or aggregate income be equal to 100 units, then taking into account both the exogenous spending plans of firms, government and foreign residents, and also taking into account household spending plans, which are influenced by what the flow of income is, then in total the economy's planned aggregate expenditure will also equal 100. So that one unique point on this diagram, the point at which the planned aggregate expenditure line cuts the 45-degree line, represents the equilibrium. Now, simply saying that that represents the equilibrium is not saying that that is necessarily what we will observe in the economy. All we have done in this slide is identify where the equilibrium is. All we've really done in this slide is take that information from the table I asked you to work through and illustrate it on a diagram. We have not yet established that the economy will be at equilibrium. We don't know that yet. All we've done here is identify what the equilibrium is. Now, before we establish whether the economy is at equilibrium, I just want to show you a third way of establishing where the economy's equilibrium is. We've done this two ways now. We've done it through the table. We've done it through the diagram. Sometimes it's convenient, and also as a check, to calculate what the economy's equilibrium must look like using some simple algebra. So let's just do this as a check. We know the economy's planned aggregate expenditure can be represented by this little equation here. We use that information in the construction both of the table and of the diagram. We know that in equilibrium, the economy's GDP must equal planned aggregate expenditure. So in equilibrium, this must be true. So what you're really looking at is an algebraic way of saying in equilibrium, we must have GDP equivalent to planned aggregate expenditure. Apologies, we should add the extra 40 there as well. Here I've just done it for you, but you can check if you like. We have an equation where we have y on the left-hand side and y on the right-hand side. So simply solve that equation for y, bring those two income terms onto the left-hand side of the equation, and you can soon see that the economy's equilibrium flow of GDP is indeed 100. This is just a quick back-of-the-envelope way of establishing what the equilibrium must be, making use very much of the concept that equilibrium is where GDP and planned aggregate expenditure are equal. So I don't really mind which way you do it, either the diagram or this, though from here on we're going to work primarily with the diagram. So let's just summarise. We have a very complete representation of planned aggregate expenditure now. We have our three exogenous components of planned injections, and I've just made up some numbers there, 10 for planned investment, 20 for government, 10 for exports. We complete the story of planned aggregate expenditure by including the very rich detail we have about households' consumption plans, noting that those plans have both an exogenous and an endogenous component. And we've seen that in this particular instance, once we know all of this structure or detail about planned aggregate expenditure, the economy's equilibrium must be 100 units of output. But as I was saying previously, identifying what the equilibrium must look like doesn't tell us whether the economy will actually be at that equilibrium. And so that's the question we must now address. Are there any automatic forces in the economy that guarantee that the equilibrium will actually be achieved? Will the economy, in other words, be in equilibrium? To answer that question, we need to add one more assumption to the model. It's a very important assumption. It's actually quite central to the Keynesian model. It's an assumption about one of the things that might motivate firms' production decisions. What we're going to assume is that when firms observe unplanned changes in inventories, they take that as a signal. They take that as a signal that tells them that they've gotten their production plans wrong, that the amount that they're producing doesn't match exactly the spending plans of the economy. And that firms will, if they ever observe this situation occurring, adjust their production plans accordingly. If, for example, firms unexpectedly see an increase in their inventories, remember they're not expecting this, to their surprise, they're seeing that they're not able to sell everything that they've sold, they'll understand that means that they're producing too much. And in response, they will cut back their production. So an increase in inventories leads to a reduction in production. If, on the other hand, they see the opposite occurring, if they see unexpectedly that they're having to dip into their inventories to meet demand, so that their inventories are unexpectedly declining, firms will understand that means they've underestimated what the strength of expenditure will be in the economy, and that will act as a signal for firms to increase their production. So firms are assumed to respond very systematically to unexpected changes in inventories. And that assumption is going to be absolutely key to understand what I've called the transitioning to equilibrium, or what we're really doing here is answering the question, will we know that the economy will eventually be in equilibrium? Or would we expect the economy to be in equilibrium? Take the following example. What we have here is an economy not in equilibrium. What I mean by that is we have an economy, I'm going to assume, producing 120 units of output. The problem is that if we take the corresponding planned aggregate expenditure that we would expect to see should the economy's income be 120, we see that that planned aggregate expenditure falls short. What the planned aggregate expenditure schedule tells us is that with income of 120, the various sectors in the economy are only planning to spend 109. So we're clearly not in a world of equilibrium. We're in a world where the economy has produced too much relative to what the sectors of the economy are planning to spend. As a result, there will be an unexpected increase in inventories. There'll be unplanned investment, in other words. It'll be 11 units. Firms produced 120, but they're only ever going to be able to sell 109. There are going to be 11 units of inventory accumulated unexpectedly. So you're looking at a disequilibrium, but you are not looking at the end of the story. And that's because of our previous assumption. Firms observe this happening. They see, to their surprise, that they're accumulating unsold inventory, unsold stocks of inventory. What do? Well, our assumption from the previous slide tells us that firms adjust their production downwards. They stop producing so much. They've taken this as a signal they've overproduced, so they cut production. Remember, production and income are the same at this aggregate macroeconomic level. A decision by firms to cut production means this economy's GDP will fall, this economy's aggregate income will fall. What happens in this framework when income falls? Well, with an income of 120, that's where we are on the consumption function. As income falls, households revise their consumption downwards, and that's shown by a movement down and along the consumption function. Put simply, households find their income falling, and therefore they cut back on their consumption. Consumption, of course, is an important component of planned aggregate expenditure. So if we're moving down and along the consumption function, we are also moving down and along planned aggregate expenditure. And these movements will continue for as long as firms are experiencing an unexpected increase in inventories. Once we reach this point, however, we have correspondence between what firms are producing and what the economy is planning to spend. We no longer have this unexpected increase in inventories. Firms therefore stop adjusting production. They keep production at 100. That production of 100 exactly matches planned aggregate expenditure, which is also 100, and we have reached the equilibrium. So what this analysis tells us is that if we have a disequilibrium where firms have overproduced, that will set a chain of events in process that eliminates that disequilibrium and moves the economy to its equilibrium. It can work in the other direction as well. Suppose we have a situation where production is 80. Now, with production at 80, we have planned aggregate expenditure of 91, and we read that off the planned aggregate expenditure schedule. What we have here is a situation of underproduction. At an income level of 80, firms have produced less than what the economy sectors are planning to purchase. What firms will experience is a change in their inventories, but in this case it's an unplanned reduction in their inventories. To meet that planned expenditure of 91, firms will have to use their previously accumulated stock of inventories to provide the extra 11 units, the difference between the production of 80 and the firm's planned expenditure of 91. So we record that as unplanned investment of minus 11. Inventories are being reduced. But that's not the end of the story. Firms see this happening, it's taken them by surprise, and they take that as a signal, well, we better increase production. And now it's the opposite of the previous slide. As firms increase production, income in the economy increases. As income in the economy increases, households increase their consumption, and we showed that by a movement up and along the consumption function. Consumption's an important part of planned aggregate expenditure, so we also record a movement up and along the planned aggregate expenditure line. And this process continues until production hits 100, because at 100 the planned aggregate expenditure of the economy corresponds to production. There's no longer an unexpected change in inventories. The economy has reached its equilibrium. So this and the previous slide are really significant. What we've established here is that there are automatic forces in the economy that lead the economy to equilibrium. And so the equilibrium point is where we would expect the economy to be. Any disequilibrium is quickly eliminated either through the process described on this slide or the previous slide. We expect the economy will be at its equilibrium.